Right now I'm in the middle of the Greenland Sea on a 30-day expedition with an incredible team of scientists studying a mystery buried thousands of kilometers below the surface. One that could reshape what we know about the deep sea and the role of our oceans in a changing climate. Here's why. Have you ever noticed those tiny white specks drifting in the water while you're swimming in the ocean? That's marine snow, a slow, steady fall of tiny bits made of stuff from living things, like dead phytoplankton, slime, tissue, you name it. And also, this will be important later, microbes. All of it carries carbon as it sinks into the deep. This feeds what we call the ocean's biological pump, one of Earth's most powerful climate regulators. But something doesn't add up. The deep sea is full of life that probably lives on carbon from above. However, when we measure how much of it actually sinks, the numbers don't add up to what life down there seems to need. So, where is the missing carbon? I'm just here to report, so let's listen to the researchers on board from the Microbial oceanography group from the University of Vienna. Let's go. So, Gerhard, where is the missing carbon?
Well, the missing carbon in marine snow is transformed by microbes, and these microbes are colonizing in the surface waters this carbon. It sinks as a particle rain into the deep sea, and it's consumed by all the food web in the deep ocean.
The team is investigating whether there are particles with unusual properties, so slow to sink that they may have escaped previous measurements, playing a role in storing carbon in the deep sea. Marilena, why is all of this important and why should we care?
We need to understand the ocean's capacity of storing carbon, especially now that we are facing a changing climate. The data that we collect out here will improve our understanding of what's happening to carbon in the ocean and how microbes affect these processes. This will help to shape global climate models and policies around them.
So that's why we are here, sampling from the surface down to 4,000 meters deep, pulling up water that hasn't seen sunlight for centuries. The team is tracking both the particles and the microbes riding on or around them by analyzing different molecular fingerprints.
So we know about this carbon source for years now, the particles, but nobody really understood its role. So any clue helps us to trace where this carbon came from and also how microbes are working on it and chopping it down in these vast and enormous oceanic systems. So in essence, if these particles really store carbon for centuries, this might change the view of the biological carbon pump, but also the deep sea systems in general.